And to get the sum of squares, we will simply sum over all such I in our data set. And that will give us, in effect, our loss function. So we have here our loss function, L, and the term loss function is the objective function that you're looking to minimize. And we're going to go into that in more detail when we talk about neural networks, okay? So we're getting a preview of that here with the very first neural network, linear regression. Okay, 1805, Adrian Marie Legendre. Squared. So that's our objective function that we have to minimize. And we spent a lot of time in our calculus chapter talking about minimum, maxima, critical points, and we particularly recall that the gradient has to equal 0 at a critical point, at the minima and the maxima. So in this case, to find the minimum, the value at which this sum of squares is minimized, we know that the gradient at that point has to be 0, right? But what's even more interesting is that for this particular type of function, it's a quadratic function, and we happen to know that it is a so-called convex function. Convex functions have interesting properties such that they have only one maxima. So this, we know, is a convex function, and therefore we don't have to worry about, is it a maximum or a minimum? Is it the only minimum? Is it the least of the minima? We can be rest assured in knowing that the sum of least squared loss function is a convex function. Okay, these are called convex functions. The term convex optimization will come up again in our upcoming 2 chapters, and therefore all we need do is to find this gradient, set that equal to 0, and solve. But what you do know is that the solution to this problem, this equation, gradient of L and B equals to 0, whatever M and B solves this, that solution gives you the only solution. So that is the only minima. So that is the correct line. Because all I need to define a line are 2 things, right? The slope and its y-intercept, and we're done. So when you solve this for M and B, when you get your M and B, you're done. And that's the linear regression problem.